managing skin exposure. So I'll talk a bit about hierarchy of controls, which most people are familiar with, and how that fits in with skin. I will give you some thoughts on gloves. It is a few slides with thoughts on gloves, and we'll talk about skincare, and overall there'll be an overview of skin management as we go through. So the skin is our largest organ. It accounts for 16% of our total body weight. In an average adult, we have 2 square meters of skin. I love that because it sort of says, you know, average adult, 2 square meters of skin. Actually, we're all different shapes and sizes, and an average adult is apparently somebody who's 72 kilograms. And I don't mind admitting that I'm a little bit more than 72 kilograms. So I probably have more than 2 square meters of skin. And one of my best friends is actually barely clears 5 foot. I'm assuming she doesn't have quite 2 square meters of skin. But the reality is it's a very large surface area. It is the outer covering of our body. Rarely do I need to explain that to anybody. We're all aware of that. It acts as a barrier to contain body fluids from escaping, tissues, all of that. We also have it as a barrier to prevent harmful substances, bacteria, viruses from entering the body and causing us harm. At the same time, it still has to be flexible and elastic. And the skin is quite remarkable in that it does actually all of that. I know I'm a bit biased. I have spent, in fact, pretty much what feels like my whole life learning about skin. Enviroderm was originally a family business, and so I grew up learning about skin in the workplace. So it's quite, you know, for me, it's I sometimes forget that not everybody has that. So the skin, it's made up of 3 main layers. The bottom layer is called the subcutis. It's also called the subcutaneous layer, subdermis, subdermal layer, adipose tissue. There are a few other names. It's got a lot of names, but it's a largely made up of fatty cells. It varies very significantly in thickness across the body, acts as a physical buffer, storage for all sorts of things like vitamin D, but also actually can be a storage for chemicals. It varies not just across the body, but it also varies at different time points in our lives. As we have more body fat, you will have more subcutis. As we have less body fat, we have less. So it varies not just on the site, on body site, but also in time. The dermis, this is the mid layer of the skin. It's largely made up of elastin and collagen fibers. And this is where we find the flexibility, the elasticity, the strength of the skin. This is the bit that keeps us looking young. And it's actually, there's a huge amount of research into the dermis and how it functions on a number of levels. One is cosmetics, but also for things like scar research. Again, it varies in thickness depending where on the body you're looking at. It varies between about 2 millimeters and about 4 millimeters. In the dermis is where we also find things like nerve endings, the hair follicle, and around the hair follicle, the sebaceous gland. So it produces sebum, which is a lipid substance. It keeps hair supple. It also goes across the surface of the skin, mixing with sweat and forming a lipid film. And I'll talk a bit more about what that does in a couple of slides' time. And we also have the capillary bed for blood is also found in the dermis. The outermost layer, the epidermis, has no direct blood flow, blood supply. It gets all of its nutrition from diffusion from the dermis, from the capillary bed and the dermis. But the epidermis is where we find the barrier function of the skin. It varies in thickness depending where on the body, but it's actually quite thin. You're looking at about 0.1 millimeters for overall thickness of the epidermis. Its main cell type is a cell called the keratinocyte, and it actually has almost like layers going up through the epidermis, so a little bit closer at it. So then we've got the keratinocyte. It's formed in the bottom layer, the basal layer. It's formed by mitosis, so you end up with 2 identical cells. One of these stays in the basal layer, the other migrates outwards. As it migrates, it changes. It fills with a fibrous protein called keratin. And by the stratum corneum, the outermost layer of the epidermis, it's become a flat, horny cell. And the stratum corneum is different from the rest of the epidermis in that these cells have lost their living nucleus. And the cells are no longer called keratinocytes, they're now called corneocytes, although they are the same basic cell. Eventually, the corneocytes are lost off the surface of the skin, and they make up a large constituency of our house dust. It is a continual process. The process of forming in the basal layer to being lost off the surface takes between 4 and 6 weeks. But it is a continual process. Other things that happen as the cells migrate outwards, they fill with a sac of complex lipids. So these sacs are called lamellar bodies and occasionally called Odlum bodies. And the lamellar lipids inside are excreted between the cells when the cells enter the stratum corneum. And they form a sort of a complex matrix of lipids in the lower part of the stratum corneum. And these lipids are made up of ceramides, omega fatty acids, and other lipids. And so they form a very, very clever matrix. Overall, I said that 0.1 millimeters in thickness overall. The stratum corneum is about 0.01 millimeters thick. Those lamellar lipids, the matrix of lamellar lipids is 2 microns thick. So that's 0.002 millimeters thick. Very, very thin. And actually, they are incredibly important because this is the layer that keeps the water in the body and other substances out. It is a semi-permeable layer. It is not a completely impervious layer. It is semi-permeable, so it does allow some water through, just as it will allow some chemicals through. So overall, it's a nice diagram, but it's actually not amazingly accurate because the layers of corneocytes in the stratum corneum, the cells are actually quite a lot thinner, and there are many, many more of those layers. Other things we actually find in the epidermis, we find the melanocyte. The melanocyte is a dendritic cell, so you can see all the little legs there. It produces melanin. Melanin is the brown pigment in our skin that gives us a lot of our skin color, our skin tone. It's that pigment that actually protects us from UV damage. So the melanocyte is the bit that gives our skin its protection from UV and actually the rest of the body. The melanocyte is genetically, we have a melanocyte that will produce a certain amount, a maximum amount of melanin. It is acted on by UV. We'll talk about that again in a minute, but it's the amount of melanin we produce is dependent on the amount of UV we're exposed to. But it is predetermined. You probably look, I'm quite pale. I recognize I'm quite pale, but actually I am pretty much really well tanned for me. I am a type 1 phototype, so Celtic phototype. Actually, if you measured my skin at the moment, my exposed skin at the moment actually comes up as a type 2, but the unexposed skin you can definitely see I'm a type 1. It means I don't really go brown. So it's one of those things. It doesn't matter how much more I'm exposed to the sun, I won't really tan much more than I am now. Other cell type you can see there in the diagram is the Langerhans cell. This is an immune cell. It's involved in type 4 immune responses, so allergic contact dermatitis. And then down in the dermis, you can see the mast cells, different type of immune cell involved in type 1 allergic contact urticarial reactions. So this makes it look, again, quite quite similar across the whole of the body. I mentioned about variations. There's a variability in the skin on different skin sites, quite a significant variability. Those two pictures on the left, in fact, all of these pictures were made with a device called the VisioScan. The VisioScan is an imaging device that is actually designed to measure texture and to quantify texture. It's used in all sorts of research fields. So the pictures on the left-hand side there, the top one is the back of my hand. So you can see it's got one kind of texture. The bottom, the one below that is actually the palm of my hand. So you can see they're quite different textures. On the right-hand side, the one on the top is actually on my cheek. So you can see actually there's a lot more pores on my cheek, and the one below it is actually my volar forearm. So you see different skin sites have a quite different appearance. And the significance of that actually can be quite profound. So here we have somebody who has a nasty rash on their hand. This is actually allergic contact dermatitis to something called sesquiterpene lactone, which in this case was found in iceberg lettuce. So this is a contact allergy to iceberg lettuce. Unfortunately, I don't actually have a picture of the palm, and I know why the picture wasn't taken, because it looked like a normal palm. And that's because the texture and the skin itself is quite tough on the palm. On the back of the hand, it's nowhere near as tough. Which is why this reaction, it's allergic response, it was seen on the back of the hand, not the palm. Part of the reason why it was on the back is also what they were doing. They were picking iceberg lettuce, and they were brushing past one, which is where the exposure was coming from on the back of the hand. It also is linked with the level of exposure. Even if you really, really love iceberg lettuce, you will probably not have the similar kind of exposure, certainly not in that location. They would pick at least one iceberg lettuce every 10 seconds. So it's a sheer volume of exposure that led to this problem. So in terms of the variability of the skin, it goes a little further than that. It varies with age as well. So this is actually skin thickness. This is measured with high frequency ultrasound. So similar to ultrasound we'd have for something looking at organs or babies, this is high frequency. So anything from 22 megahertz upwards allows you to look at the skin in detail. The higher the resolution, the more in detail you can look at the skin, but the shallower the measurement. So what these images are showing, you can see there's sort of like a white strip on the left-hand side of these images. That's actually the epidermis. The green chunk next to it is the dermis, and then the bit beyond that is the adipose tissue, and actually getting down into things like muscles. And what you can actually see is somebody at 28 years old has a much thicker and actually also more densely packed dermis than somebody who is 20 years older. It varies again because of genetics, because of lifestyle choices. It is actually affected by nutrition. If you change your diet, you can actually improve or actually make your skin thickness get worse. So there are various things we can do that change it. So I guess what I'm trying to say is the skin is highly variable across most of the body, and depending what we're doing with it, it can impact how it performs. Some of the things that the skin actually does for us are many of these will actually impact the skin. So the weather. Cold, wet, windy weather, the skin protects underlying tissues from that. At the same time, cold, wet, windy weather will have an impact on the skin. So will very hot, humid weather. So there are some impacts on the skin, and we often see, particularly in climates like the UK, you will see some seasonality in skin problems, in part because of changes in the weather. Although this year it's probably been less noticeable, certainly in the UK, because we seem to have had an awful lot of what feels like wintry weather for a lot more of the year this year. There are some other aspects to why we see seasonality. One is actually to do with our natural skin oils. I mentioned sort of, sebum lipids that go out over the surface. That lipid film, it's involved in moisture balance in the skin. And we actually produce less of the sebum in the winter than we do in the summer months. If you look at a lot of the animal kingdom, certainly, I mean, I live on a farm, we have animals, so we see it with, we have a few sheep, and we see it with our sheep that their levels of oil change depending on what point of the year we're in. They produce more oil in the summer than they do in the winter, very much like human beings. And actually, we as human beings probably need more in the winter than we do in the summer. It's an artifact of evolution for us. For the sheep, actually, it's very well balanced for them. So the weather and oil production is one of the ways in which you get seasonality in skin problems. We then have physical damage. The skin, it is our defense against physical abrasions. Simple things like opening a door, there's a certain amount of friction that goes through the skin. It's why different areas like the palm are much tougher than other areas of the body. And we know that physical damage can be a significant factor in irritant contact dermatitis. It can make the skin more susceptible to all sorts of other problems. It can make the skin less of a barrier for chemicals, for infection, a whole host of things. But the skin, considering what it does, considering it's made up of cells, it's actually quite remarkably robust. We then have UV protection. linked in with the weather. There are 3 forms of UV, UV A, B, and C. Most of us are not generally exposed to UVC. It's absorbed by ozone. It's created in some work tasks like arc welding. All of us will be exposed to UVA and UVB unless we never go outside in daylight. So we're all exposed, and they do, the amounts, the intensity will vary throughout the year, particularly in climates that have more seasonal variation. You will get greater light intensities in the summer than in the winter. And when you look at UVA and UVB, they've both got some upsides and some downsides. So UVB is actually the trigger for production of melanin. So I mentioned before that UV affects the melanocyte. Well, UVB is the trigger for producing.
Yeah.
The more
That'll be lovely.
UV we're exposed to, the more melanin we'll produce to our maximum. So mine's not very high. If I have my husband in here, he's doesn't look that much darker toned, but he is more like a type 2 or type 3, so he produces more melanin. He will get more tanned than I will.
Helen, you've muted. Yeah.
I don't know why I muted.
There we go. You're
okay.
back.
So UV. I don't know how much you heard of UV. So what it is, A, B, and C. Just recap that. A, B, and C. C is absorbed by ozone. Most of us aren't exposed to it. A and B we are all exposed to. They both have up and down sides. UV B, it's the trigger for melanin production, so it acts on our melanocytes, and the more we're exposed to, the greater the intensity, the more UVB we produce. The less melanin we produce to our maximum. When we look at different phototypes, even within families, you can have some differences. My mother's half Scottish, so she is where I get my nice Celtic skin from. On my dad's side, his grandmother was Spanish, and so there's some Mediterranean toned skin in the family. I inherited the Scottish. My sister inherited the much more olive toned skin. She goes brown much more easily than I do. So you will get differences even amongst families. UVB, it's also the primary cause of sunburn. So there are some upsides. It produces melanin, but also actually it burns the skin. UVB can cause skin cancer, but it also triggers production of vitamin D. So UVB is a double-edged sword. We want a certain amount of it, but we don't want too much. So it is about balance with exposure. UVA can also cause skin cancer. However, it does have an impact on microcirculation, and there are thought to be some beneficial effects of that. It also inhibits the immune system. So UVA is another component of why we have seasonality of skin problems. Greater UVA light intensities will dampen down many skin problems, not just occupational, but non-occupational as well. So things like psoriasis, and in fact, we use it in many treatments. So psoriasis is a type of treatment called PUVA. Psoralen UVA, which is high intensity, short burst UVA with psoralen, which makes the skin more hypersensitive to the effects, and it dampens down the immune system. Eczema is another one that can often be seasonal due to UV exposure. Downside of UVA, so cancer is one of them, but also the biggest impact of UVA is actually to do with elastin and collagen. UVA damages elastin and collagen. So UVA is a very significant component of aging of the skin. So, you know, if you like sun exposure, particularly if you like to go on sunbeds, you will have the impact of UVA. Sunbeds work either exclusively or predominantly on UVA. So they are mostly cosmetic. UVA does not trigger melanin production. UVA redistributes existing melanin. So a UVA tan is slightly different from a UVB tan. The timescales are one of the most noticeable things. A UVA tan is quick. So it comes up very quickly. So if somebody says, oh, you only have to look at me, you know, the sun only has to look at me and I tan, that's a UVA tan. it's usually found that kind of reaction is found in people that will produce more melanin, but the immediate part of the tan is not offering additional protection. Research has shown that it actually offers maybe an extra 1 or 2 SPF from your natural protection. UVB, it takes time because it's that melanocyte poking melanin into the cells migrate outwards. So the maximum on a UVB tan takes between 4 and 6 weeks to reach. And that's because it's 4 to 6 weeks for the renewal of the whole of the epidermis. So there are some upsides and some downsides of both. There is another little fact about UVA, which is quite interesting. UVA goes through glass. So if you spend a lot of time driving, and pre-COVID, I spent quite a lot of time driving around the country. I have right side damage to my skin. I drive a right-hand drive car in a, where we drive on the left, so the damage is on the right side of my face. If I drove on continental Europe or in the US, the damage would have been predominantly on my left side rather than my right. And that's because it's UVA going through the glass. If you can't see it very well on camera, which is really unfortunate, but up close, and if I showed you my forearms, you would see that my forearms, my right has more and bigger freckles than my left. Until I point it out to people, nobody would notice. But it is something that actually, when it's pointed out, you can see. And again, that's the visible signs of that UV damage. It's in most cases permanent damage. I have a measurable difference between my right and left sides with both wrinkles, mechanical properties, and some other aspects. So it is something that can be measured. And the only other thing I will say about UV before I move on is about SPF. I always make the assumption that people know this, but I'll say it anyway, just in case. It's about SPF, because I know that in the general population, there's a lot of misunderstanding about what it actually means. And there's a lot of talk about high factors and wearing high factors. What the high factors do is they multiply. In fact, any SPF, it multiplies our natural protection. An example would actually be a comparison between myself and my husband. If we went on holiday to the south of Spain in August, I would have something like 2 minutes of natural protection before I start doing damage to my skin. That's not 2 minutes and I'll be burnt, but 2 minutes and I start doing damage. My husband has maybe 20 minutes. So if you actually take a factor 50, I have 100 minutes in the sun, where he has 1,000 minutes in the sun. So the underlying natural protection of an individual will affect how well the product, or how much time a product will give us in the sun. And you often see people sort of, well, the product didn't work very well on me, I've got burnt, but you didn't get burnt, your product must be better than mine. Actually, it's about underlying conditions of the skin. So I mentioned before vitamin D production. UV triggers the vitamin D production, and the skin is actually a main source of vitamin D. The consideration actually in our modern times actually comes from when people go from a location geographically where their skin is, if you like, designed for that location, and move somewhere else. So in my case, if I moved somewhere really hot, along the equator, Africa, I would have an issue with sun exposure because my skin's not designed for that environment. Here in the UK, it's really well designed for the UK, so I have no problems with vitamin D production. And in fact, although most of us are thought to end the winter vitamin D deficient, I am less likely to have vitamin D deficiency problems than, say, somebody who was born in Africa and has moved to the UK, where their skin is designed for a much hotter, more intense UV environment, and therefore it protects them much better. You put them into an environment in northern Europe where we have lower light intensities, therefore there's not enough for them to produce enough vitamin D. So whilst it's not occupational health related, it is something that we need to consider as the overall well-being of people in the workplace and out of the workplace as well. Chemical protection, certainly something we think about in the workplace. The skin is a protector against chemicals. It helps stop chemicals getting entry to the body. I say helps stops. It's not an impervious barrier. You'll often see people talking about it and talking about formulas and that where they refer to the skin as like a membrane. It is actually a semi-permeable membrane. And that's because we have the barrier that keeps the water in the body. It's the thing that keeps the chemicals out, but the outer layers of cells, they do still need water. It's a much lower water content, something like 10%. However, it's very important that the water is in those cells. So it's a semi-permeable barrier, allows a small amount of water through, keeping most of it in the body. So what this actually means is it's also semi-permeable going the other way. If you want to actually look at some kitchen science experiments with permeation, skin permeation, you can do this with garlic and onion. So if you cut a clove of garlic and that flat cut edge you rub on the skin, I would use something like the volar forearm because it's a little bit more permeable than the palm, or perhaps the back of the hand. You rub it on the skin, waits of 15-20 minutes, you should be able to smell garlic on the breath. The other is with onion. And there are two aspects to why our eyes tear when we're cutting up onions. And it's the liquid inside that acts on the tear duct. And the first part is it becoming airborne, and it has a direct effect on the tear ducts. The other is it going through the skin and reaching the tear duct from inside and triggering it. So it's that situation where you're cutting up an onion, you think, oh, it's not too bad, my eyes aren't tearing, and then wham, your eyes are streaming. That's the point where it's gone through the skin and reached the bloodstream. Wear goggles when cutting onions, your eyes will still tear. There are, two ways where you can avoid it entirely: goggles and gloves. Not that I'm saying that's a good idea, I'm not. Or cutting an onion underwater. And this is something somebody said to me actually quite a few years ago now, and actually there's some quite sound science behind that. If you're cutting an onion underwater, the liquid doesn't become airborne. And if you're cutting it underwater, it's diluted, so less goes through the skin. I would say that I don't actually cut my onions underwater. What I know is that when I stop cutting the onion, eventually my eyes will stop tearing. My fingers don't grow back. And that's probably a reflection of how well I cut. I'm no master chef, but I don't. So the risk to me is actually, or the hazard is actually greater for protecting against the liquid inside the onion than it is actually for the effect itself. So it is about sort of risk and control. When we look at chemicals, the only other thing I should say is we tend to think with chemicals it's all about the ones that are labelled as hazardous. Actually, the single most common cause of occupational skin problems is actually water. That's the single most common cause of any one chemical. So we're actually, with the skin, talking about everything. Every chemical can have an impact on the skin. Then we have microorganisms. The skin is one of our primary defenses against microorganisms, and it has a couple of aspects that are quite important. It's a physical barrier. The surface, that lipid film I talked about on the surface, it's actually acidic. And that acidity helps retard colonization and penetration by bacteria and viruses. And it's one of the reasons why when you're handling things like electronic components, sometimes you handle them with gloves on to stop the oils from the skin, that lipid film actually getting onto the components. It's also why we handle very old documents with gloves on, again, to stop the lipid film getting onto the documents and causing damage long term. Another aspect of the skin is we have our own microflora, our commensal bacteria that live in the skin that form part of that defense, preventing colonization and penetration. Currently, the terminology, which actually is it's actually smart terminology, is the skin microbiome, because there's quite a sort of almost like a whole ecosystem of bacteria that are in the skin that form part of the function, part of that defense. So when we start thinking about looking at products for cleaning the skin, we need to remember that we have our own microflora. So whatever we do to remove the nasties, we don't want to actually damage our own microflora, as that's part of our defense. Sensory perception. The skin has a role in telling us about the world around us. We have a number of sensory organs in the skin that tell us about things like pressure, pain, temperature. Very important for getting on with life. Simple things like, you know, opening up a refrigerator and picking up an egg, you know, picking up an egg off the side. We use the pressure sensors in the skin of our fingertips to tell us how hard to grip that egg so we don't drop it, but equally so we don't crack it. I said that I've had a long standing learning about the skin. A lot of that actually comes from my father, sort of learning alongside him. When I was a child, he decided to test the whole sensory perception and loss of pressure sensors, and had a local anaesthetic applied to the skin of his fingertips, then realised he couldn't actually pick up eggs because he couldn't tell how hard to grip them, so he didn't crack them, but equally didn't drop them. Mum was not best pleased because we had no eggs left. My sister and I thought it was hilarious. I must say, it was, you know, as a child, it was very funny. Thorough science, you know, some of, you know, but it's an example of how those sensory organs are very, very important to normal function. And then we have thermoregulation. We're warm-blooded. We need to remain within a certain range of temperature, and the skin has a really important role in that. We have changes in blood flow depending on whether we need to lose heat or conserve heat. So hot weather, the skin gets pinker because the blood goes to the surface to promote heat loss. If it's cold, we get paler because the blood diverts away from the skin. We then also have the sweat function. If we're very hot, we need to actually get heat out of the body. The sweat function turns on. It will turn on initially as very sort of low level perspiration, right through to droplets of water on the surface. And it's the evaporation of that water that cools. Something to remember when we put people in full coverage chemical protective suits is that the function of the sweat evaporating, once inside that chemical protection becomes saturated with the sweat, it no longer functions as it should. So it's just bearing that in mind when we're looking at protection. Other side of that is if we're cold, we will have, you know, so we go pale, sweat function switches off, and we will also see goosebumps on the surface. These are sort of evidence of hairs across the surface of the skin standing up to trap air. Works like double glazing, where you actually have an air gap that reduces heat transfer. We've seen from sort of thermal imaging cameras, it's very effective on the top of the head with people who have hair and those that don't. Across the rest of the body, I'm not sure the studies have actually been done to look at the exact benefits of it, but certainly it would be less effective than most of our pets like cats and dogs. And lastly, but by no means least, is moisture control. I mentioned that layer, it's semi-permeable. We need the skin to keep most of the water in the body. It is a continual process of loss of water though. An average adult can lose as much as 3/4 of a litre of water through their skin a day. So it is a continual process. Sweat is on-off. You sweat or you don't sweat. Transepidermal water loss, as it's called, is a continual process. 24 hours a day, 7 days a week. So when we talk about things like gloves and having sweaty hands in gloves, actually, if it's freezing cold and you're not sweating, the water inside is transepidermal water loss. And in fact, there will always be transepidermal water loss build up inside a glove. So no, that's quite a long slide, that one. The skin, it's thin, it's under almost constant attack. All of us will mistreat our skin from time to time, even those of us that really should know better. It is, however, an amazingly resilient organ. We can push it too far, but it is actually quite resilient, quite remarkable. However, around 20% of people at any one time will be suffering from a skin problem. That, I believe, is a UK statistic. Is actually pre-COVID as well. And I'm not quite sure how they work that out, because there are a lot of skin problems that go underreported, but it gives us an idea, a ballpark, 1/5 of the population. Not all of these will obviously be work-related. Many of these will be constitutional. Why one person develops a skin problem whilst others remain unaffected, we have some understanding, but it's by no means complete understanding. So I'm just going to very briefly look at overall skin diseases. And on this diagram, I broke them into 2 basic groups. So those that are dermatitis, those that aren't. Of those that aren't, we've got some that are possibly occupational, some that aren't. In those that are dermatitis, we've got exogenous, which is a fancy way of saying contact, and endogenous, constitutional. Now, a diagram like this makes it look very black and white. There's actually a lot of grey areas. The first grey area is that something like psoriasis, it's a non-occupational skin problem. You have to have the underlying condition. The underlying condition is not caused by work. However, chemical exposure and stress can actually make it worse or cause an outbreak. It's the same with eczema. That's the first thing. There are elements where work can exacerbate or cause an outbreak of a condition. The other thing that we also need to recognise from a workplace point of view is just because a skin problem is not occupational does not mean we can ignore it. And by that, I don't mean that we should be looking around for causes and treatments. It's more about understanding if the skin is not functioning correctly, then it may not be providing the same level of barrier as we think it is, and therefore our control measures might need to be different. So irritant contact dermatitis, it is by far the most common problem. It's a non-immunological effect. It's caused by chemical or physical damage at the site of the effect. The biggest thing to note is an irritant damage affects everyone. It's the amount that varies. You may not see or feel the damage when it's occurring. And in fact, in most cases, you don't. When it's acute, it can have blisters and swelling. Most of the time, if it's more chronic, you'll see dry, red, itchy skin. So I said it's a cumulative effect. What you have is every time you come into contact with an irritant, so that can be windy, cold, wet, windy weather. It can be chemicals at work, chemicals at home. Some damage is done. The skin is remarkable. It repairs the damage. But over time, we have a buildup of damage, and this is completely unseen. The skin will look normal. It's not until we break through our threshold that you see the signs. At this point, hopefully we do something. The skin can recover, so it does come back down below the threshold. Before you break through the threshold, it does bend, it does sort of, adapt. Once you break through the threshold, it does lower. But once you get back down below the threshold, the skin will look normal again. However, it still remains fairly close to breakthrough. So what is quite typical of chronic problems is they come and go at irregular intervals over many months, many years even. What we actually need to do is allow people to get far enough away from their threshold that it can be managed. If all you've done is given somebody time off work or put them in a different work area and you put them back to what they were doing, it's not if they will have a problem again, it's when. We have to make changes. Some of those can be small changes, because many small changes can actually make a very big difference with irritant problems. There does come a point if you do nothing at all where the skin loses its ability to repair itself. It's quite rare, but it does happen. So this is quite a good example of irritant contact dermatitis. You've got the dryness, a bit of flaky red skin. So this is quite typical of something that's early days is not too severe. So here I've got two pictures. These are both my hand. They're both the same hand. You may look and go, well, okay, spot the differences. There are some slight differences in the light. They were taken at different times. The biggest difference actually, though, is in the hydration levels. The one on the left, normal hydration levels. The one on the right is actually after repetitive washing of the hand to actually cause some clinical damage. So this is showing that level below the threshold. And we can actually measure various things with the skin. There's some that are really quite cool, but not actually very useful in a workplace setting. Things like elasticity. Really, really good to know whether you're good, bad, or indifferent for your age. However, it's looking more at changes over a longer period of time. And the equipment is also quite expensive. Some of the more user-friendly is transepidermal water loss. And if there's time at the end, I've actually got some equipment that we can actually look at. So this is the water that passes through the barrier and evaporates off the surface and gives us an indirect measure of barrier function. So it's an indicator of barrier function. The next is hydration. So this is the water that's actually in the epidermis and the stratum corneum. And as the skin is damaged by irritants, it loses its ability to bind water because it loses natural moisturizing factors. So we can think of hydration as general skin condition. The lower the figure, the more damage. So we've also got allergic skin diseases. These are malfunctions of the immune system. Starts with sensitization that then can lead to allergy. It is possible to be sensitized and not allergic. Everybody who's allergic is sensitized. They are whole body effects and they're usually permanent. The one on the left there is actually allergic contact dermatitis. The one on the right is allergic contact urticaria. They're not that dissimilar. They often look very, very similar. The time scales, which you don't see in a picture, are the bit that varies. Allergic contact urticaria's immediate type comes up very quickly. The one on the left is a more delayed reaction, so it will come up slower. This is an example of airborne dermatitis. This is very, very fine particles that couldn't be seen with the naked eye in the environment. If we have something like this and we suspect it's airborne, we obviously can do monitoring. We have to link in things like a diagnosis of an allergic reaction. We need to link in with exposure and make sure there is exposure. We had not this case, but a similar case of facial dermatitis from a gentleman who had a formaldehyde allergy. There was a coating on tin cans that did contain formaldehyde. They assumed it was this that was causing his facial dermatitis, but actually it couldn't be measured in the atmosphere. So it wasn't the formaldehyde in the atmosphere because there wasn't any. What actually turned out to be is he was diabetic and drank exclusively diet soda drinks. And most of these contain aspartame, and for some, aspartame metabolizes in the body and produces formaldehyde. So his formaldehyde allergy was being triggered from the large volume of diet soda drinks he was drinking. That's something called systemic contact dermatitis. So this skin, you can see where this is behind the ear. This actually was for somebody who wore safety spectacles, but not all the time. And he'd done exactly what had been suggested. He'd taken his safety spectacles and gone to the lens cleaning station and did exactly what the name suggested. He cleaned the lenses. What he didn't do was clean the arms of the spectacles, and behind the ears we have quite a lot of that lipid film of sebum. Sebum can be quite sticky. It was coating the arms of the safety spectacles, and he was storing them in a pocket on the work surface, and they were getting coated in chemicals, which is what caused this reaction. Other things we can also measure is actually colour, redness. Eye is very good at distinguishing colour when separated, but when separated by space or time, it becomes more difficult. So there are measures which we can actually measure skin colour separate of our subjective measure. So we can quantify and monitor a rash. Skin exposure, often seen as not particularly serious. This actually is an extreme case. I will admit it is an extreme case. This individual was laying a concrete floor. He was wearing jeans and work boots. His jeans got soaked in concrete, and the cement caused third-degree burns. Before he realised that there was an issue, it was a bit too late. So third-degree burns in both his legs, and unfortunately for him, he had gangrene in one of his legs and it had to be amputated. This isn't a very common occurrence, I will say that. This is actually a case from about 97, 98. But burns with cement, a bit like sunburn, by the time you start feeling the heat, it's a bit too late. And this actually, I've got this picture in here because it just highlights another thing we need to think about. What we often find is people think of the skin as a barrier that is only breached when we bleed. And sure enough, if we bleed, we have breached the barrier. The barrier, though, is found in the very outermost layer of the skin. And in the case of this individual, they've lost most of their stratum corneum in their finger, a large chunk of the palm, and their thumb. So this person, actually, their life was at risk. It may sound very dramatic. They have no barrier and a large chunk of their hand, and where they worked was a rat-infested building site, and they were picking up things with their hands, components that were left on the building site, and the first thing you saw in the mornings on the building site was rats running for cover. So the chance of contracting leptospirosis much, much higher for this individual over somebody else with intact skin. So it comes back to what I was saying, that even if it's not work related, we need to just consider how that skin condition impacts the working environment. And also don't overlook psychological factors. The emotions cause immediate changes in water loss, blood flow, sebum production. It's a well-known thing that stress can affect many skin diseases and affect how people recover. So with the skin, very simple, no contact, no problem. So when we're doing investigations, looking at what's happening, it doesn't matter how allergic somebody might be, how potent a chemical might be. If there's no contact, there isn't a problem. And so sometimes it's thinking about where that contact comes from. This individual worked on a building site, had a little problem, a skin problem. When asked, well, can we see your hands? He said, well, it's not on my hands, it's here. Lifted his arm and showed the red raw patches underneath his arm and his armpit. And then followed that up with, my doctor thinks it's something I'm wearing. So, you know, try and keep a straight face at this point. Well, carry on doing what you're doing. See anything, we'll let you know. They're filling that formwork with concrete. And you can see the pipe there. And every so often that pipe needs moving, and this is how he moves it. And if you look closely at that image, you can actually see where there's cement or concrete dust on his bicep and his chest. And it's immediately obvious from that image where the exposure is coming that's causing a skin problem. So looking at the workplace, we need to look at the strategy for risk management. So we design workplaces and equipment to eliminate exposure, select chemicals for minimum hazard, install engineering controls, handling equipment, safe working procedures. CPP falls quite well down the list. And then we've got minimize the effect by limiting the exposure. And the reason why this hierarchy exists, so I'm sure you're aware, is that we control the process, it lies with management. You control the person, it lies with the worker. We can make a system fail safe, we can't really make people fail safe. Initial costs of controlling a process might be higher, but the medium and long-term costs are usually lower. We control the person. Actually, the cost, you know, provide them a pair of gloves, but if they don't use them correctly, the long-term costs are inevitably going to be higher. So I've got a couple of examples of control measures. So this is a paint spray booth, and they're using paint spray guns. They're cleaning the guns at the back of the paint spray booth, and they're in a flow of solvent, as well as you know, taking a third of their work time to clean the gun. And it was a bit of a bottleneck in the factory. What we suggested was a bit of investment, an extra paint spray gun, and one of these. This is an automatic paint spray gun cleaning station. So what they now do is spray the first paint, they turn around, put the dirty gun in the paint spray gun cleaning station, hit start, and it's contained, so there's no solvent exposure, it's all inside. They pick up the second gun, use the next paint, turn around, get the clean gun out, put the dirty gun in. So it improved productivity as well as eliminating the exposure. What we need to do when looking at controlling exposures, we need to make sure that we control, that we're looking at solutions that control the problem, and that we don't focus too much on trying to fix failed solutions. This is a good example of that. The problem here was that paint came out the openings where the tiles are going in and out of the paint spray process there. So what they've done is it was coming out, so they put in ducting and a fan. They then found that the fan got blocked with paint, so they put in a filter. They then found the filter got blocked with paint. The problem here actually, you know, they're still talking about filtering, you know, rotating filters, all sorts of things. But the problem actually isn't filters or fans. The problem is the paint comes out the openings. So instead of ducting to extract the paint, the recommendation was air knives to blow the paint back in, and then it could be collected like the rest of the way of the unused paint and reused. A simple but alternative solution. This next one is actually one of the simplest, can be used in so many settings. They were reaching up with a brush to brush swarf oil coolant out of a piece of equipment. And it was running down the brush, down the handle, and causing problems on the hand. So what they'd done is they'd put the individuals into pairs of gloves. And what they then found is it ran down the handle, down the glove, and caused problems at the wrist. So they got a longer glove. But of course it ran down the handle, down the glove, and caused problems at the wrist. So it's just moving the problem down the arm. The question came is, you know, could we use a longer glove? There are longer gloves, but the problem is actually it runs down the brush. So this actually involved a quick trip to the DIY store and buying one of these. And this is a plumber's plunger. Very simple piece of kit. But if you pull the handle out and you drill a hole, you can poke a brush back through. If you're clever, you seal it with sealant. You've now got something that collects whatever's running down the brush, so it never gets onto the handle where you're holding it. It can be used in many, many ways. So PPE, there are some 4 basic ways they fail. I'm actually going to talk about gloves, but it actually applies to all PPE for skin protection. There are 4 basic ways: misuse, physical damage, degradation, permeation. Misuse is using the wrong glove for the task. This is a cotton and leather glove with chemicals, completely the wrong glove. This next one is actually a glove too short. You can see there's a gap between the overalls, which are contaminated, and the gloves. And if you look at the left hand, you can actually see on the arm there's contamination, and that's quite clear. Storing them where they can become damaged or contaminated. Other things for misuse would be not donning or doffing gloves correctly, not storing them correctly. There's a whole host of things. Using them for longer than they should be. So this is actually physical damage, but there should have come a point where this individual said, well, actually, I've got a hole, so I shouldn't use it. This next one is absolutely misuse as well as physical damage, because this individual decided to modify their gloves for better dexterity. When you look at them and say, oh, fingerless gloves for chemical protection, not a great choice. Then we have degradation. So this is actually a solvent protective glove sitting in a solvent. However, it just so happens it's not a solvent that it works very well with for degradation, because after a few minutes, these are the fingertips. They've lost their physical strength. They no longer provide the protection that we need. And then the last one is permeation. So this is where the chemical goes through the glove at a molecular level and comes out on the inside. There is no glove material that is unaffected by all chemicals. So this goes for degradation as well as permeation. We do testing, and we test to work out the breakthrough time, so how long it will take for the chemical to go through the glove. The data we collect is specific to that glove. The reason being, as you'll see from the next chart, is that actually glove thicknesses vary, and that will impact how well the gloves work. So this is actually data from a manufacturer, from Ansell, with some of their different materials. You can see there's quite a lot of different glove materials there with varying levels of protection they offer for acetone. So we've got some like LLDPE and butyl, Viton butyl. They actually offer quite good protection. The Viton, not so great with degradation. Then you've got things like nitrile. The nitrile listed there on the right hand side, you've got 2 there, which are actually both quite thin nitrile gloves, and you can see they offer very little protection. So the 1 and the 3 relate to minutes of protection. So very, very low.
Excuse me interrupting. We've just got 2 minutes to the end of the hour.
Yeah,
I just wondered
I've not got that many slides. I've got about, I think I've got about sort of, 3 or 4 slides of
okay, that's fine, as long as everybody's happy to stay. I think Dave's got to go now, but he said he has to go, so yeah okay, but do carry on, because if the rest of you are all right, Michelle and Sharon, yeah, okay, let's go, carry on.
So permeation is affected
enjoy
by
the presentation.
Thank you, Dave. Thank you.
So permeation is affected by a few things like degradation, mechanical damage. Mixtures can decrease breakthrough times. There are also things that can increase breakthrough times. So our data is actually our starting point for them working out how long we can use the glove. So it's not just simply, oh, well, it'll last for 480 minutes, well, you can use it for that. The other thing to recognize is that actually permeation starts from first contact. It's not 15 minutes today, 15 minutes next week, 15 minutes the week after. It's actually the 480, if you've got that length of protection, it is from the first contact. So skincare. There are some rules for good personal hygiene, good skincare. The longer we leave soiling in contact with skin, the more time it has to do damage, the more difficult it will be to remove. However, we need to balance that with all cleansers cause damage to the skin. So we want to avoid excessive washing or try and mitigate the excessive washing. We need to use the correct cleanser, which is actually the mildest that will adequately remove soiling. I ceased to be surprised at what people would use on their skin. My personal favourite was in a dockyards where they were using Swarfiga and a Scotch-Brite pad to clean their faces. And then they thought it was the oil and grease from bilges of ships that was actually causing facial dermatitis. You've got to use the right thing in the right way. A Scotch-Brite pad is not a great cleaner for the skin. Wash hands before using the toilet as well as after. Just think about something like chilies, very tough skin on the palms. You put your chili on the hands, actually you won't probably feel it, won't burn, but you touch the face, you'll feel the burn. It's that same thing. Yes, there are areas of the body that are far more delicate than the palms of the hand. We need to wash and rinse in running water. Otherwise, we're rinsing in dilute dirt. It needs to be thoroughly rinsed. So actually, if we're taking our 30 seconds to apply a soap, we need to do the same to remove it. If we don't remove all the soap, it will have a chance to cause more damage to the skin, but also we're not removing all the dirt. In terms of temperature, the correct temperature for hand washing is actually 32 to 35 degrees C. I know you can't pump water around a system like that because of Legionella at that temperature. However, you can have hot and cold feeds and mix a tap. If you haven't got a mixer tap, use the cold water. That one in the picture is actually a thermostatically controlled infrared mixer tap. They're great so long as you actually set them to the right temperature. 32 to 35 is actually lukewarm. We use hot water when we're doing, for example, doing the dishes. We do that so we can break down grease, so we can melt the grease on the dishes. It'll do the same to the skin here. It'll do the same to that lamellar layer. It's a great matrix at skin temperature. Heat it, it doesn't do it a huge amount of good. It will settle down, but if you are repetitively washing your hands in hot water, it will long-term cause some damage. The other thing is actually hot water is not the most comfortable thing to wash your hands in. And if it's too hot to put your hands under the tap, then you will have people that don't wash their hands properly. And it's one of my personal pet hates. You go places and the water's too hot and they put a little yellow symbol above saying caution hot water. If it's water that's meant for washing hands, just sticking up caution hot water, all you're doing is admitting it's not fit for purpose. We need to make sure it's at a temperature that is usable. We need to dry the skin completely. Ideal is actually something like toweling, but that's not practical. So the best option after that is good quality paper towel. And once we have dried the skin, and we need to use a moisturizer. That lipid film on the surface, great for moisture balance. It takes an hour to 2 hours to replace it when we wash our hands, or our skin. So using a moisturizer allows the skin to function correctly. The odd time where you don't apply it, it's not the end of the world. However, if you are repeat washing your hands, for example, a couple of times an hour across a shift, the whole of that shift doesn't have proper moisture balance in the skin. So that's why moisturizer, when we can, is good, but not under gloves. Under gloves, all you're doing is adding more water to what will create hyperhydration. And last couple of slides. We need to also remember that it's our skin 24 hours a day. So we have our work, we also have sleep, and we have domestic leisure activities, second job, all sorts of things. And it's often perceived that things outside of work are safe. And I have had this said to me on a number of occasions, they wouldn't sell it if it wasn't safe. This is nail polish remover. You can buy it in any pharmacy, drugstore, supermarket. It's an acetone-based nail polish remover. When you actually look at acetone, it has a defined protocol for patch testing. It's not got a hazard statement, but if you actually look in one of the great works on patch testing, it has a defined protocol for how you would test for allergies. But if you look at safety data sheets, these are some of the things you find. Skin irritation can cause coughing, wheezing, headache, nausea and vomiting, dizziness, lightheadedness. Actually, one of them even referred to there being loss of consciousness. It can cause motor incoordination, speech abnormalities, hematologic changes. So it's not very nice stuff. We know that from the workplace setting. That you probably can't see it from the picture. That nail polish remover is actually 98% acetone.
The problem, sorry, yeah, the problem there, I come across it all the time. It's classified as a cosmetic, so you
Yes,
don't
it is.
have to label it,
No, they don't. Absolutely.
which is
They don't.
ridiculous.
Yeah. And yet, if you use it as acetone in a workplace, you have to have a safety data sheet and consider all the hazards. And it's one of the things we need to recognize is that outside of the workplace, there are plenty of things that can cause damage. And when we're looking at workforce training, things like acetone nail polish remover are a great way of going, yep, you can buy hazardous things outside of the workplace. And in the workplace, we saw that data. You need to use NLDPE gloves or butyl gloves to provide protection for longer than a few minutes. I don't know any supermarket that sells those gloves. I've never seen them. And that's sort of the reality of life with chemicals, and certainly skin exposure. And that's it. That's my last slide of information, other than my contact details. If you've got any questions, happy to answer them now.
So, thank you so much. That is absolutely excellent. I've heard some of your earlier presentations, but this is, again, it's just on a different level entirely. It's brilliant. But can you imagine telling somebody to wear gloves for nail varnish remover? It's kind of...
Actually, I'm absolutely. And I have a friend. I have a friend who is part of what she did, and in fact she's branched out to podiatry, but she was a nail technician. She started her own business, then had skin problems on her fingers, and what she was doing was these high-end ones where you paint them on and you cure them under light. And then 12 months into running her own business, she had problems with her fingers. She's very house proud. You go into her house, it's pristine. You know, she's forever cleaning down her work surfaces. So there was damage there, as well as during doing what she was doing. And there's a big difference exposure-wise between having your nails done every 2 to 3 weeks and doing them several times a day.
I'd hate one of my kids. I think of all the jobs, and I'm including even construction in this, in terms of all the effects, beautician or nail technician, it's probably one of the most hazardous ones I've ever come across.
Hairdressing, yeah, hairdressing.
And hairdressing. Oh, yeah. Sorry, I missed 2 things there. Apologies. I hope everyone else doesn't mind. Did you say not to put on a moisturizer before putting on gloves?
Yes.
Okay, that's
the reason being is that you put it on for moisture balance. When you put your hands in a pair of gloves, because of the transepidermal water loss, you do not have moisture balance. That is actually one of the biggest issues with gloves. And when you talk about permeation, all this, and and so what a moisturizer. And
gloves are seen, gloves are seen as the solution, and they can cause even more problems.
Exactly. And when you look at moisturizers, what they have a lot of is water. And if you look at the ingredients on a moisturizer, you know, the ingredients are in sort of, you know, largest amount first. And when you look at the water, usually it's the first or second, you know, ingredient in there. They have a lot of water in them.
Sorry, just one more. Lettuce. I had some today, and I'm kind of going, what have I eaten now? What's the chemical in it, and is it naturally occurring?
It's naturally occurring. It is a naturally occurring chemical. It's actually found in all lettuce.
What's the name of it?
Sesquiterpene lactone.
Oh, okay. Thank you.
And it just so happens that iceberg lettuce contains significantly more. And you know, I always say to people, if you don't like iceberg lettuce, feel free to use it as a reason never to eat it again. But if you like it, don't worry about it, because it's sheer volume. You know,
they are Sesquiterpene.
Sorry,
can you say the name again, please?
Sesquiterpene lactone.
Okay.
Lactone. And it's also about the location. You would never usually, as an individual preparing iceberg lettuce, have contact between the back of your hand and the lettuce. Certainly not for the amount of time they do.
Yeah.
Oh yeah, yeah.
The location, as much as the amount of exposure, is actually a combination of the two. The palm was problem-free. So it wasn't the actual holding the lettuce that was the problem, it's the brushing past the other lettuces that was causing the problems.
Okay.
Yes, on the back of the hands too. Yeah. So that.
Sorry, you mentioned aspartame metabolism. Does it metabolize to formaldehyde in everyone, or is that just?
I know. I don't believe it's everybody. I think it's some. And for that individual, often it's, you know, we're not talking huge amounts. The problem for that individual is, yes, he was diabetic. He didn't like tea, didn't like coffee, wouldn't drink milk, wouldn't drink water.
Yeah.
Doesn't leave much else. And so it was just everything he drank contained it.
Okay. So another 10 things to add to my don't eat list.
Yeah, and actually it's you know, I'm not saying don't drink it, don't.
Oh, I know. Yeah, I know.
It's all about the quantities, and in that case, it was just the sheer volume of it that he was consuming. You know, every you know, it probably just wasn't just drinking. If you think about it, most things that are for diabetics, they contain artificial sugars.
Yes.
Of which aspartame is probably the most common.
Yeah.
So
it's like PKU, you know, it's not. Yeah.
Yeah, it's all about the level of exposure that makes the difference. And there have been some very interesting cases where people have had, there was one lady, it's not our case, we heard about it in a dermatology conference, but she had nickel allergy that developed from wearing suspender belts in her 20s. And in her 40s, you know, she stopped using suspenders, you know, simple solution. And she changed her diet in her 40s, did a whole food, health food, you know, healthy diet, lose some weight, that kind of approach, went to Whole Foods in her 40s.
Oh, and the nickel was released.
And the nickel, trace element nickel, was enough to trigger systemic contact dermatitis. And what was most interesting about that case, which is the bit that really sticks in my mind, is where you saw the patches of allergy, of the reaction, were exactly where you would have found the actual clips on a suspender belt. So the skin has a memory. And it's, you know, it's quite a fascinating case. So, you know, it's the skin does have a memory. We don't understand how, why, but it does. So yeah, diet is, you know, we talk about you are what you eat. Yeah, we are, and it does impact you. You can improve your mechanical properties of your skin. You can make your skin look more youthful by having a diet that's higher in ceramides and omega fatty acids. And there's a whole raft of beauty supplements now which have collagen, ceramides, and omega fatty acids. And there's studies that have shown that they improve the density, the depth, and the mechanical properties of the skin, as well as things like hydration and barrier function. But we know that diet impacts how the skin functions as a barrier as well. So omega fatty acids and ceramides will improve barrier function. It's not a magic bullet of fixing skin problems, but it's something we can use. I said many little changes. Dietary changes can have an impact on the skin. Sleep will have an impact. And the other really sort of snippet information, which is quite an interesting one, is the skin. I said it's not the same across the whole of the body, across timescales. It's also got a circadian rhythm. So it is more permeable at night than it is during the day. And, you know, it's why you have night creams and day creams. But it's also, you put that into a workplace context where you have shift workers, and then start thinking about it's more permeable at night than during the day. And it's not the biggest thing we have to consider, but it is just another element that we need to just have in the back of our minds. Do any of you have any more questions?
I probably could ask about 100, but no, it's a fascinating area. It's absolutely brilliant. As I said, I've heard your presentations before, but I always learn so much at them. So thank you so much.
That's okay.
Yeah, I'd be interested in the name of that whole food. Sorry, that food you mentioned that it seems to prevent allergies. Perhaps you can email that.
Yeah, so there's a number of different supplements. They don't really sort of help with allergies per se. What they do is they improve the barrier of the skin. Which, yeah. So, and actually, there are quite a few of them around. It's it's almost like an explosion in beauty nutritional supplements. But then there are a number of companies I know that have done research that links with them. So, you know, email me and I can drop you some information.
I'll email you.
You know, there are several companies that do the research, and actually some of them have been doing research in that area for quite a few years.
Oh, wow.
Yeah, Helen, that was really
Fascinating.
interesting. Yeah.
Very interesting.
Would you mind sharing your email again? I think I
Ah,
saw it on the slide, your
yes,
contact.
I will just put that back up.
Yeah.
And yeah, so feel free to email me with any
Okay.
questions.
Enviro. Thank you very much. That was great.